So in this video we're going to find the residues of our function here, pi cosec pi z over 2z squared plus 1. And this video I'm going to show you what's called the g over h rule, or the differentiation rule, for finding the residues. So first of all, let's find the poles. So 2z squared plus 1 tells us probably 2 poles. So let's first of all solve that. So 2z squared plus 1 equals 0. Z squared equals minus 1 over 2. Z equals plus or minus I over square root of 2. So there's our poles. That's our 2 poles, as we assumed from the z squared. So let's call this the g over h rule, or the differentiation rule, where g is pi cosec pi z and h is 2z squared plus 1. Both of these functions are analytic, so that's one of the first conditions taken care of. And also h needs to be 0 at the poles, which we've just calculated from this, that is the case as well. So now we're okay to go ahead now and differentiate h. So h prime is just 4z. So now we set up f of z in the form of g over h prime, which is pi cosec pi z over 4z. So now we're all set up, ready to go. So now let's find the residue of the positive one first. So residue of f at I over root 2 equals pi cosec pi I over root 2 divided by 4z. So that will give us 4i over root 2. Okay, so we can make this denominator 2i root 2. That's fine. That's if you do 4 over root 2, it becomes 2 root 2. Now this pi I root 2 in here is a little bit of a problem. We've got to change this cosec and put that into the hyperbolic cosec. So let's just go with that now. So that now equals pi hyperbolic cosec. And now it's just pi over root 2. Divided that by 4i over root 2. So that becomes 2 root 2i. Okay, let's see if we can get the I on the top. So 1 over I becomes minus I. So that becomes minus I pi hyperbolic cosine pi over root 2 divided by 2, what am I writing pi for? It's 2 root 2. 2 root 2. Okay, so this is our first residue. Just write that down here for what that is. That's the residue of f at I over root 2. So now let's find the negative version. So let's just draw a line under that. So the residue, let's not write it, yeah, let's write it here. Residue of f at minus I over root 2 equals, put minus I root 2 in all these bits here, is pi cosec pi minus I over root 2, and then put minus I root 2 into here, 4 I root 2. Okay, 4 root 2 we know is 2 root 2, so we can set that up straight away. So that's 2 root 2. This I here can move up to the top the same as the way we did that one, and that becomes minus I. And then the cosec pi minus I root over root 2, that then becomes the hyperbolic cosec. So pi minus I pi hyperbolic cosec of pi over root 2. Okay, and then that gives us our residue of, let's write that here, residue of f at minus I over root 2. All right, thank you very much.